I'd like to talk about hydrogenation, and specifically I'll talk about hydrogenation of a ring, an alkene ring, because this does have stereochemical um, consequences. The first step in hydrogenation is that we have hydrogen and there's a palladium catalyst. Now the palladium catalyst is typically a metal that's been adsorbed or bonded onto something like carbon, and then what happens is the hydrogen bonds to the palladium, and it bonds in two separate single bonds, and you can see the arrows here. The electrons from the HH bond are used to form a bond between the palladium and the H, and then two electrons can come off the palladium and bond with the other hydrogen atom. What can happen then is that the ring can come down and bond with these two hydrogens, and again you see this simultaneous system of arrows that show that the hydrogen is going to add from underneath the ring. So we're always going to get cis addition of the hydrogen to the ring. So that's why when I've done this, you can see the hydrogens are pointing downwards while the methyl groups are pointing upwards. Alright, I want to make this a little bit clearer. So when you're drawing these products, I want to point out that it doesn't really matter about the direction of these H's. I mean, it matters whether they're sticking up or sticking down. But if I chose to put a dash here and put the hydrogen here, and put the hydrogen here, that would be the same as doing this. Sticking the hydrogen out here. In both situations, we're dealing with the same thing. I just want to point out that where these two are in relation to each other spatially in the diagram doesn't really matter as long as we've got the right situation going on here with the wedges and the dashes. The wedges always just mean pointing up and the dashes always mean pointing down. Let me see if I can get a better picture here of what's happening in the step when the hydrogens are adding to the alkene in the ring. So this alkene I'll see if I can flatten it out a bit. So what I'm trying to do there is to show an alkene ring that is flat. It's in the plane. It's going in 90 degrees to the plane of the screen, sort of in and out. And these are actually in the plane of the screen. So look at the arrows as I draw them. This one is showing that two electrons from the CC bond are forming a bond now between this C and this H. Two electrons from this palladium hydrogen bond are going back to the palladium, and now the two electrons in the palladium hydrogen bond here are now forming a bond between the C and the H, and this bond is breaking. And that's a breaking bond as well. All of this happens simultaneously, which allows for us in the end to have our cis addition of hydrogen to the double bond.